So let's see what is the role of pressure in bioprocessing. So now we have talked about the temperature, we have talked about the agitation. Now we talked about the pressure. How pressure helps the uh, how pressure helps basically to maintain the bioprocessing, to optimize the bioprocessing, and to produce the best quality product through these bioprocessing. So pressure play a very significant role besides temperature and agitation. If the besides good temperature, optimum temperature and agitation, the containers or the vessels or the fermenters or bioreactors could not maintain the pressure, it will affect the yield of bioprocess product. Now, what is the role of pressure in the bioprocess? First, we talk about the role of pressure. So, as we discussed earlier, that sterility maintenance is very, very important. What does a sterility means? It maintains a slight positive pressure to prevent the contamination. So, contamination here means you have to be careful about the container not to get mixed or exposed to various non desirable or undesirable microorganisms, right? For example, if you talk about the especially human or mammalian cell lines, in mammalian cell lines the contamination is very, very common and obvious sometimes if it is exposed and not properly handled. Then what happened, these sterility will lost and there's a contamination of the some bacterial cells. So if the mammalian cell lines got contaminated with the bacterial or some other fungal uh, contaminants, then it will totally spoil the growth. It will totally spoil the quality of the product based on that mammalian cells. Bad smell, then it could have like slow in yield, and it may not produce the ample amount of the cells to grow for the bioprocessing and so on and so forth. So the whole bioreactors basically, so through small leak or opening of these bioreactors, it might contaminate. So pressures is basically is important to maintain these sterility. Now then gas solubility control is also important. What is the gas solubility control? It's directly influences the oxygen and carbon dioxide, because oxygen and carbon dioxide play a very important role for the growth, uh, because in the culture sometimes it depends on what kind of a culture you have. For example, if you are talking about the mammalian cell and if the CO2 concentration is reduced from 5% of the CO2 in the incubator, then that will impact the cell growth, right? And similarly oxygen is also very important, right? So carbon dioxide and oxygen for aerobics and anaerobic conditions is very important to balance and to maintain in the fermenters, which is directly affecting the cellular respirations and of course pH balance, because pH balance is also maintained by some acid production, CO2, use of CO2, especially in gram-positive cells. Suppose if you're talking about the S mutants or S aureus, they have acid producing cells. They might produce acid, and CO2 is required for them to grow, and lower depletion of oxygen is required for growth. So the gas solubility and the balance of CO2 and O2 is important for good bioprocess product. The process safety is again the pressure monitoring ensure the safe operation within the design limits, preventing the equipment failure and maintaining the operator safety. Now, process safety is important because if the pressure is not properly maintained, and then it might not be safe for operation within that design limit. Sometimes if it is high pressure, if it is cross the required pressure, then it may have sometime equipment may fail, or it may take some some technical flaw, technical defect. And so maintaining the operator safety is also important. Sometimes it get blast because of high pressure. So the maintaining the operator may have like at risk in that case. So we should be very careful about the safety for the manpower as well as for the safety of the product. So therefore the sensors and the pressure sensors are important, and pressure sensor monitor both headspace and liquid phase pressures is required. It provides the comprehensive data for process control and safety system. Now the pressure control system, it precisely control the pressure in the bioreactors, which affect the everything from sterility and gas transfer to equipment integrity in order to maintain that equipment for the safety purpose. implementing the robust pressure management system, safeguard operations and optimization of critical biological reactions, right? Now, the pressure sensor utilized for the real-time monitoring various sensors, various sensor types. Then we have a piezo, then we have a piezoresistive, capacitative, strain gauge. So these are all internal system to maintain or to gauge, to sense the pressure level and provide the display on the machine. Now, provide the accurate pressure reading to ensure the process safety and prevent the equipment damage. In that case, the equipment can also be protected. A back pressure regulator is another category where you can sense the pressure's maintenance and maintain the constant upstream pressure by precisely controlling the outflow, uh, that is outlet flow. I mean of the processed product or the nutrients inflow, and this is essential for stable gas uh, sparging, filtration, and chromatography, ensuring the consistent process conditions of this bioprocess product. So in the real-time manner, we can regulate the pressure through back pressures, and we can maintain in the byproduct. So safety is also important. The relief values, relief valves is basically these critical safety devices automatically activate to release the express. So there's a valve system, and these which can relieve the pressures as and when required to maintain that pressure. So when the pressure is increasing, then you have to maintain the pressure through these valves, and the excess pressures protecting bioreactors, piping, and personnel from potentially hazardous or pressurization event. So this is basically slightly release the pressures time to time whenever they're required after the sensors detect the designed or controlled pressures or required pressure to be maintained in that bioreactors. Then sterility and gas solubility we already discussed, but again here from the perspective of proper pressure management, it prevent the contamination by maintaining the positive pressure and to make the sterile system, the whole fermenters and bioreactors, and enhance the solubility of the critical gases like O2 and CO2 for optimal cellular metabolic processing in the growth. So by effectively managing the pressure of bioprocesses can achieve in high quality, high quantity, best productivity. It reduces the batch failure, and it also extends the lifespan of the this valued product. The pressure control techniques where we can control the pressure are automated valve system. So there we have a valve system where the valve can work, and these valves are basically of different material they have made, and because the temperature is also there, so the valve should not be lost, should not be damaged for the functioning of this valve at that temperature at which the pressure is maintained. For example, in case of autoclave, we have the gaskets, and these gaskets act as a valve. When we release the valve gas, so the steam is released out. So it should not, it's 100 degrees centigrade or even higher than 100 degrees centigrade, 120 degrees centigrade temperature. So that valve material should be of such kind that it may not be affected. So it regulates the gas flow and venting the automatically based on the pressure and like set points of different types and different maintain the optimal conditions without manual intervention. Now, suppose if you are keep manually maintaining the pressure, it might not control as and when required. So these machines are manufactured in such a way that they have some maintained sensors, and these sensors are properly these sensors are properly controlled in a way that they can have better sensitivity and better accuracy rather, and precisely they can detect the what pressure is required, and that's how we got automatic valve. So whenever the pressure is increased, the valve slightly release the gas, release the pressures, and if the pressure is like not maintained, suppose if you take the example of very homely like pressure cooker. So in pressure cooker, you have, although it is not sort of automated system, but I think it's a manual system. It's still they have made a mechanism where there's a vessel on the top of the pressure cooker. So when the pressure so they made the weight of these vessels is very important, and the valve that they maintain in this in the pressure cooker is again the size of the valve, in the amount of steam released out from this valve is very important. So accordingly, they design the pressure cooker. It's not like a simple like you can make any kind of a weight. The weight is has certain meaning. You cannot put like any weight on this pressure cooker. So when you put this vessel which has a weight, and when the pressure build up, excess pressure comes, the vessels it removes the vessels, and the valve is open, and then through this opening the weight, the valve release the pressures, and there's you like you listen the whistle kind of a things कहते हैं सीटी आ गई. So this is nothing but this is like excess pressure is being released out from this taking out weight. So the weight which is put on the pressure cooker is important. So this is how you have to design that, but that's sort of not very automated system, but I think it's still they have some logic designing the weight. Similarly, some sensor systems are there, so they can provide the automated opening of the valve and closing of the valve to maintain the pressure in the bioreactors. The pressure relief system provide the safety protection, because again I take an example of pressure cooker. So if suppose in a pressure cooker, if you do not have, suppose if a valve is closed, sometimes valve is by some some dust or some like deposition, the valve get closed, choked, and then you keep putting a pressure, keep putting like a you know half an hour, 1 hour, you're cooking the food, and there's no whistle out of it, because I mean it seems like there's no whistle coming. It means the valve is not opening. So when the valve is open, it will remove the through steam. It will remove the whistle, and when the whistle is slightly removed, there's a the weight is slightly removed. There's a sound of whistle, sound of city whistle. And if you're not able to hear this whistle for a long time, it means there's a risk. You should be very careful about that, to go close to the pressure cooker, because it might burst, it might like blast out because of the over more pressure, and the container which is made for a certain pressure limit, when the pressure limit exceed, then it will like blast, and that has happened sometime, and it may cause like a safety, it is a big risk factor, and the safety factor is also important here to uh, properly relieve this pressure time to time. And so pressure relief system is very important. It provides the safety for protection of the manpower which are using these machines during fermentation. So automatic venting system is there properly, which can control the pressure, release the pressure if it is exceed, and equipment may not be damaged, and also the operator safety is important. The SCADA integrations is enable the continuous monitoring and data logging process, like how you can log the data, and then provide the operator with the real time fermentation. Data logging means like you can keep monitoring the data. I mean, kind of what is the pressure at this time, what is the temperature, what is the pressure, what is the temperature. So this whole data, continuous real time data, can be logged in, and provide the operator for the real-time information about the historic trends of process of operation optimization. So accordingly, for example, at this temperature pressure, what is the optimum product yield? At this temperature pressure, what is the optimum yield in this particular machine, in this particular bioreactor system, right? Or this pressure control techniques system. Therefore, the operator can easily monitor and can get an idea and access and guess that, okay, this is the condition where we can have the best quality product, right? So they can choose that. Similarly, pH monitoring control is again important parameters, where you need to have pH monitoring and control system, because pH is again important factor or important variable in fermentation process, where uh, you can precise pH control in different manners, in different because different bacteria may have optimum growth at different pH, and the nutrients which are used and the media which is used of maintain a different pH. And if the pH slightly change after product development, or after the nutrients, excessive nutrients being put in the bioreactor, then this imbalance or loss of balance of these pH will also affect the growth. So maintaining the optimum pH, ensuring the consistent growth, quality and growth product, the bioprocess product, efficiently and precisely. Therefore, pH sensors are also important. Manually you can You can sense the pH through various devices. We have the pH strips, which can have gradients of a pH on it, and you just dip stick, and this dip stick basically give you the slightly change in the color of a pH, and you can monitor the uh, scale, the what is the range of pH you are in and your product is. But for the fermenter process, I mean, for the process where you have the, you know, these bioreactors where we have like a gallons of nutrients and materials are used, and to maintain the optimum pH, the common type of includes the traditional glass electrodes. So sensors in a glass electrodes are used, which give you the, these electrodes are put in the, sometimes you can put in the real time sort of thing. So it can give you the sensor on the display on kind of a machine on the top of the machine. Uh, this electrodes accuracy is called ion sensitive field effect transistors, right? Transistor sensor for the robust, like miniaturized and stabilizable in situ measurement. All right, calibration procedures. How to calibrate this pH? So regular 2-point or 3-point calibrations using the certified buffer solution, which is important to ensure the sensor accuracy and reliability over extended process run. All right, and buffer system is biological buffer systems such as the phosphate or or bicarbonate. So these are the two buffer system. Phosphate and bicarbonates are frequently used to maintain the pH, and these buffers are providing the specific pH under different conditions, right? And they are incorporated into the media to resist the pH increase or decrease, any kind of a change in the pH, and maintain the stability in cell culture environment. So whatever cell cultures are used at different in different nutritional conditions in different media can be well maintained through these pH conditions and maintain the pH. Now the buffering. So buffer is basically provide the buffering cushioning the particular range of pH in which the bioprocess product can work optimally, and we have good optimum growth and conditions for that. Now automated control of pH is again uh, automated system like utilize the feedback loops to precisely control the pH by regulated addition of acid or base solutions, ensuring the process remain within the narrow and target range. pH stability is critical for optimal enzymes activity, because the enzyme activity, the enzymes which are used for the bioprocessing are against a particular substrate or bio raw material on which the enzymes works to produce, for example, uh, molasses, right, producing alcohol, or or sugarcane molasses producing the alcohol, for example. So you must be careful about the use of enzymes in that raw materials, so that the both the raw materials and enzymes could have better uh, stability, better kind of a compatibility, sorry, in order to produce this substrate into convert into the product. So for that, what pH is required so the enzymes can work under that condition is very important to understand. So directly impacting the yield process. If it is not properly maintained, it keep fluctuating or changing, then it will directly impact the yield of the product. And of course, besides yields, quality is also affected. The impact on the quality is also there, and so we can have lower good quality product may not be obtained. Effective pH management minimizes the stress conditions of biological system which is used for the bioprocess product, and we have a good product development if we can regulate it. Otherwise, it's difficult to prevent the product loss, right, and ensure the economic viability and biomanufacturing operation. Now, the dissolved oxygen is also important. In dissolved oxygen measurement, the accurate measurement of oxygen, which is used for this dissolved oxygen, is important. So, there are certain parameters, or there are certain sensors are required. We call the very common sensor, which are optical sensor, mass spectroscopy sensor. Then we have polarizographic electrodes. So, generally, polarigraphic electrodes are used for traditional robust sensors consuming the oxygen, and they can detect the oxygen in the suspension, which require the frequent calibration suitable for general bioreactor monitoring. Right. Whereas the optical sensors are non-invasive, and no oxygen consumption, offering faster responses and reduces the drift, ideal for precise long-term monitoring process. So they're used in various advanced bioreactors. Mass spectroscopy is again provide the highly accurate real-time multi-gas activity for both dissolved and off gas system dissolved, and this complex and expensive best for the researchers and critical process. What happens in the mass spectroscopy, you need to have a separate electrode, a separate setup, and that can detect the uh, dissolution of the gas through mass spectroscopy. And the mass spectroscopy give you the deflection signals on the machine or on the system, like computer system, where you can detect what is the level of this oxygen dissolve in the process. Either the dissolution lead to some product formations, or affecting the solution or suspension, give you some different spectra on that. So to monitor the oxygen transfer rate OTR is also crucial for the bioreactors design, and how you design the bioreactors, what are the, because everything is depends on the impeller design especially, or the whole bioreactor design, in order to maintain all these parameters of oxygen dissolutions, temperature, pressures and all. And if your design is something, so before you design the bioreactors or fermenter, you must know about the, the impact of these variation of these factors like pH, temperature, pressure, dissolved oxygen and gaseous interface. Now nutrient monitoring and feed strategies is also important. What are the different nutrients which need to be monitored, and how the monitoring and how the feed strategy is required. Now, the precise nutrient monitoring and optimized feeding strategy. Feeding strategy means like you can have a here the concept of the batch and fermenters are very important, where we discussed in earlier lectures, very, from one of the few lectures in this series, that batch cultures means like you keep growing the cells in a particular batch, and maybe 10 hours, 20 hours, 2 days, 3 days. But the cells get exhausted after a certain period of time, depending upon the nutrients, depending upon the time, conditions, and so on. But in case of continuous culture, you will not reach to the stationary phase. No, you will keep moving exponentially till you continuously providing the culture, the nutrients to the media. Now, therefore, the nutrients monitoring is important, and we have using the tabutometers, we use the several spectrophotometers, and we use like tabutometers, we use some chemostat, where you can chemicals nutrients monitoring can be detected. So for that, different sensors are used depending upon what kind of a nutrients are being used or regulated. For example, glucose sensor. So real-time monitoring of a glucose is important, as it's a primary carbon source. So enzymatic electrochemical sensors, it provide the rapid, accurate data for precise and feed rate adjustment, optimizing cell metabolism and product yield. Now, these glucose sensors are very, very important in order to maintain the real-time monitoring. Similarly, amino acid analyzers. So in amino acid analyzers, the monitoring amino acid profile essential for protein synthesis, cell growth, typically for HPLC and enzymatic assays. And this ensures cells have efficient efficiently uh, producing the bioproduct by utilizing these nutrients. So to what extent you are providing the nutrients, what is the concentration of these nutrients, that is in this case amino acid. So amino acid analyzer will give you a particular, all these things can analyze. So sufficient building block preventing the limitations and can impact the productivity process. Automated feeding system, and these systems use some pumping system we call peristaltic pumps, and these peristaltic pumps also used for development of a gradient sometime. Here it's not talking about the gradient, but I think peristaltic pumps are also used for gradient development. And peristaltic pumps, they control the softwares for the precise sterile delivery of nutrients to the fermenter or bioreactors. And this automated system can maintain the optimal nutrients concentration. So what is the optimum nutrient concentration required for a particular time period in order to produce the best quality product? So you can have across the batch of the product development, maintain a certain level of this feeding system, or you can increase or decrease depending upon your requirement. The feeding strategy is like a batch, fed batch, which can keep like in one batch. Again, you can feed in another batch, but continuous fresh medium is also important. You can continuously inflow of a medium, and you can produce the product in best quality. Whereas the only batch culture will not work here, because in that case you have a saturation point come at certain uh, point of time, and the yield of the product may be reduced. You may not attain or get the best quality yield in best quantity yield in particular time period. So effective nutrient management prevent the substrate depletions or accumulation, leading to more robust culture and consistent high quality biopharmaceutical product or bioprocess product. Advanced sensor technologies, this is our optical sensor, spectroscopy method, then you have a biosensors. So all these sensors like near infrared sensors, Raman spectroscopy enable the real-time monitoring. So these are high technology machine, high technology setup for at industrial level, where the large quantity of the bioprocess products are being made, both through optical sensors, and some biosensors are also used. Nanotechnology, use of nano sensors are also regularly, people are using in many cases. These biosensors are incorporating biological recognitions of these elements for highly specific detections for target compounds, offering the exceptional selectivity for process monitoring applications. Uh, I think now we have a data acquisitions, and we call a SCADA system. This is called automated data acquisitions, where we have some mechanism of, for example, if you set some data, for example, this is the temperature, this is the pressure, this is the pH required. That set data is already fed to the or programmed into the machine, and we log this data. So the continuous automated system that is recording the critical process, for example, when you run the machine, that is biofermenters or reactors, then the temperatures, dissolve oxygen, pressure. They provide the detailed audit detail of these like data processing, and it compliances also the process of analysis. Now, alarming system is also there, where we have a configurable alarm notifying the operation deviation. For example, if slightly deviation takes place, you will see the alarm signals, and these alarming signals give you the like a tone, like a beep, like some kind of a some noise or some indication. And these alarms are basically you know alert you that okay, this is some defect, and we have to fix problem, like we have to dissolve oxygen, we have to change pH, we have to maintain the pressures and so on. So this all can done through this automated system. Then historical trending, like visualizations, analyzing the historical data, real time long term data, for example, data which have a troubleshooting data for earlier data, and that data will support you to optimize. For example, under these conditions we modulate the data, under this condition we have this product. So suppose if you are attaining that conditions and it is impacting the product development, you can again quickly maintain that conditions which are required for the best quality product and best quality cellular processing. The the mesh integrations, like a seamless integrations of manufacturing executions of the system, how to execute the manufacturing system, like we call MES. Link the process of data and batch record. So what is the data of a particular batch, and uh, what is the role of that batch, and how the batch was. So all these data processing can be controlled through this data acquisition and SCADA system. Now, PID control system is again, we have proportional and integral, respond to the current or the current errors. A large difference between the set points and process variables results in a stronger corrective actions, and provide the quick initial responses, but can lead to a persistent offset. Addresses the accumulated past errors in case of integral. So these are kind of PID control system, in which the proportional integrated deviation PID control system is most common feedback control. It provides you the feedback system in a control, in kind of a loop industrial processing of the product, and give you the parameters which are required for this processing, and how the product was maintained, what are the yield and quality and quantity of the product, and what were the parameters which are used to get these yields. All these things kind of give you the feedback through control systems, and you can have give it the signals to the SCADA and get the data generated. From the data, they give you the signals, and signals will provide you, okay, this is the best quality product, opt in, and this condition. So you have to opt this condition for the several batches. This is third one is derivatives. Now react the rate of change of errors, right? And anticipating the future deviation, future how you can have, so you can simulate the future deviation based on the data. You can extrapolate the things, you can change the, you can look into the possibility of the change in the conditions where you can have a best quality. So the bottom line is that how would you get the best quality data through these things? So the dampness, oscillations, improve stability, reduce overshoot, how it can sensitive to process noises and all kind of things can be. Now the tuning these parameters like kp, ki, kd, integration, derivation, proportional, we call KPKI, KD, is crucial for the optimal performance, ensuring the stability, minimal overshoot, and rapid responses. So this is the best quality and very ideal system for bioprocessing. PID control should be required for all these precise maintaining and regulating the bioprocessing to get the best quality product. With this, thank you very much. If you have any question, you can ask later on. Thanks a lot.